Yes, it has started recording.
Thank
Okay,
you.
okay, okay. And bye, Doc. Good afternoon, everybody. Is everything still all right? Can you?
Afternoon, sir.
Yes, yes. Can you see our dear board here is clear? Ne?
Yes.
Yes, sir.
Okay. Now, welcome again. Don't forget, just to remind you again, you stop us at any time, any moment. This session is yours. It's not mine. It's ours. So if you feel like we are leaving you behind, please let us know. We better repeat this, whatever, as many times as possible until we are all together. Now, any question from especially from the previous session? Did you try those three approximation rules? The Simpson, the trapezoidal, and even the midpoint.
Yes,
Did you,
sir. I did.
everything went well?
Yes, sir.
Only hearing one person, but don't worry. If you haven't, then you still have a chance. You can just email me. Then I will definitely respond. Okay. Now, but no. Before, with the midpoint, I think I didn't mention this. With the midpoint, that is the mid ordinate. Remember, if you have something like this, let me just write it. I don't think I've mentioned this. If I did, then I didn't emphasize it enough. Say you have got what? The it's the same color. I thought it's a different color. The cover is black, but it's not black. Then where is my blue marker? I don't have it again. So let's say you have this. Let's say this is the first part. Maybe this is another part. Don't forget, we have said what? They must have equal length. That is from here to here. Must be the same as from here to here. And maybe x1 here is whatever. Then you have got, let's say x0, x1 here, x2. Let's say from x1 to x2 is whatever. Let's say is what? Let's say is 3 units. From here to here, say is 3 units. From here to here is 3 units. Or let us start with x0. Or it will depend because it doesn't matter where you are x. Say this is now x0, this now is x0. Now we are saying from here to here is 3 units. We're talking about the mid ordinate. It's 3 units. Let me write it. 3 units. Then what will be its midpoint? The midpoint, it will just be from here to here is 3 units. Therefore, the midpoint, it will now be 3 divided by 2, which is 1.5. Then it will be 1.5. That is this now. Somewhere here, it will be 1.5. Then in the book or even in the last session, we have said what? Now find the midpoint here. How to find the midpoint of this one? We have said is this and divide by 2. That from there it will give you the midpoint here. And what I'm saying is all what you can do or what you can still do is what? Just find this one. Then from there, keep on adding this. If you find the midpoint here, then add this. Remember, this is 3 units, is from here to here, plus from here to here. And because from here to here is the same as from here to here, and is the same as from here to here, therefore, once you find, especially if you start at 0, once you find the midpoint of the first part, which is this, then this one, to find this one, to find it, the next midpoint, you just need to say this, then you keep on adding 3 units. To find the next one, you just add 3 units, then that's it. Unlike finding from here to here, unlike taking this one and this one dividing by 2, thereafter taking this one and this one divided by 2, which is a little bit lengthy. I'm not sure whether we make sense. I'm saying that will be the shortcut. Does it make sense? Yeah. That is how your document approach it, which I'm saying is a little bit lengthy. So you can just keep on adding, keep on adding, keep on adding. Add the length, I'm saying adding the length, so on and so forth. Now, today is about is learning unit. I'm not sure whether it's learning unit 3 or what, or module 3 or what, but it's about matrices. Now the question is, what are matrices? Today we will just look at the definitions and the notations and whatever, and finish this with the operations. Operations meaning the addition of, and then the subtraction and the scalar multiplication and everything, and then and even multiplication. Then next week it will just be about how to find the inverse. Then the other week it will be the last one. Now, how to apply the inverse to solve linear systems, that is to solve equations. In second, that we call them simultaneous equations. That's right. But now, as we all know, mathematics is a language. We all know, we all agree that mathematics is a language. It has got its own terms, that is terminology. It has got symbols. It has got notations. It has got whatever. Then if you don't understand that language, that mathematical language, that is, if you don't know the definition of something, maybe you don't know the notation of something, maybe you don't know what a certain symbol means, the chances are what? You are not going to answer properly. They will say factorize. Then you have to know, what do they mean by factorize? Where do you stop? And some students, obviously it's not you, some students, they will be asked to factorize, given an expression and say factorize. And because they don't know this notation, they don't know exactly what is meant by factorize, what is expected of them when they say factorize. They will factorize, yes, then they will even go further in what? And solve for x. Then you will be penalized, because the question is just say factorize. They will ask them to find the roots. Now from there, instead of finding the roots, then they will find the turning points and whatever. That is why I'm emphasizing this thing of knowing the notations, the language in that chapter or in that section or whatever. Now the question is, what are these metrics? Or matrices, plural matrices. Now, matrices is mathematics. It's a chapter in mathematics. Not forgetting that mathematics is just what? It simplifies everything. It takes something in real life, you write it using mathematical language, mathematical symbols, then it will not be written in a compact, in a reader-friendly, in a more manageable way. And that is one of the applications of matrices or matrix, every singular. And what is a matrix? A matrix is what? Any rectangular arrangement of objects. A rectangular arrangement, you write something like this. It's rectangular. Otherwise, if you didn't use it as square brackets, then you cannot come and say it's a matrix. And we give it a name. Normally, we use capital letters. Therefore, it will be matrix A equal to. And inside, then you write objects. It can be real numbers. It can be complex numbers, whatever. Then say you write 3 here, you write 4 here, you write 7 here. You can see that they are written horizontally. Then we call it this horizontal line. We call it the first row. Then from there will be another one here. Say you write this. Then this red horizontal line is called the second row. This one will now be called the second row. And then this first horizontal line is called the first row. So on and so forth. You can add another horizontal line here and say -4, whatever, -7, 1. And this, it will now be called the third row. And as you can see, we still have these vertical lines because we are talking about the horizontal lines. Horizontal line. You can see that these are also written vertically. This now, the first vertical line, we call it the first column. That is one, that is column. This one, it will be the second column. This one, it will be the third column. And this now, objects now, we call them elements. These three is an element. This is an element. This is an element. This is an element. But as we have, these elements, they can either be real numbers or complex numbers, or they can even be variables. You can see, you can say this is X, this is Y, this is Z, this is W, so on and so forth. But the fact is, we are going to call it this is an element. And now, these three here, it is an element of which row? Of the first row. And which column? Of the first column. What about this one? It's an element of which row? We start with row. It's an element in which row? Is in the first row. In which column? The second column. The same thing with -7 here. Is in which row? Then you count. Oh, this is the first row. This is the second row. This is the third row. Therefore, -7 is an element of the third row. Which column? Second column. That is generally, if you have got a matrix A here, generally, say you have got this. Then you are now going to say this is A11, meaning A11 here, it will be 3. Now you can say A12. What is A12? In our case, it will be 4 because 4 is an element. These numbers, the first number refers to the row. And then the second number refers to the column. The first number here is 1. It's a subscript 1, meaning is in the first row. What about 2 is in the second column? Then that will be 4. We will be talking about 4. What about 7? Is still in the first row. And which column? That is the third column. So on and so forth. You can see that the -3 here, it will be A because it's in the second row. Then we're going to say 2. Which column? The first column. Then we're going to say it is. What about 5? It's still in the second row. Second row. Which column? Second column. What about 0? It's still in the second row. Then it will be A, 2, 3, so on and so forth. So generally then, it will not be until A1N, because everything here is in the first row. Then N here, it will be the number of column. Then this, it will be A2N, that is generally. Then this one, it will be until it will depend on the number of columns. It will be, say, M, then it will be 1. Because what is changing here is only the number of rows. Is 1 row, the first row, the second row, the column, it will stay the same, it's a constant. It will be 1, 1, and until 1. And then this one, it will be A what? Anybody?
M2.
It will be M2 because the first one, it refers to the row. And everything here, it will be row M. The same story, this will be AM3, until the last one here, which will be A what? Because it's still in the M row. Therefore, it will be M. Now, which column? You can see that the column here, it will be N. That is generally. If your matrix, you call it B, then this will just change to B what. If you call this matrix C, then you just need to change the A to small c. That is generally how you write a matrix. Now, the next thing is what is called an order. What do we mean by find the order? What do we mean by what is the order in this matrix or the order of this matrix? By order, we are referring to the number of rows and the number of columns. So here we are going to say what is the order of A? The order of A, it will be how many rows? 1, 2, 3. Therefore, the order of A, it will be, you start with 3. Then you say multiplied by. Then from there, the next number here, it will be referring to the columns. How many columns? 1, 2, 3. Then this, it will be this. Therefore, the order of A, if they are asking what is the order of matrix A, then this, it will be 3 by 3 matrix. If you have this, let's say you cut this out. So what will be the order of this matrix A now? Not forgetting that you start with the number of rows. So what will be the order of this matrix now, if it is something like this? Anybody see for I know see for this one, you can get it. So what is the order of this matrix A? Anybody?
3 by 2.
It will be 3 by 2 because the first number refers to the number of rows. How many rows? 1, 2, 3. Therefore, it will be 3 by, then how many columns? 1, 2. Then this, it will be a 3 by 2 matrix. I'm seeing if they are asking about the order, because that they may ask you that, and maybe for half a mark or for 2 marks or whatever. So this one here that I'm erasing, it will be a matrix of m by n. M by n, because we have said it has got m rows, therefore it will be m multiplied by how many columns? N. Therefore it will be a m by n order. That's right. Now, as we have said, one of the main aims of matrices is to take what? Something that is not mathematical, maybe statistics or whatever. Then from there, code it. And then from there, present it in a compact, in a nice, in a reader-friendly manner. In your book, they're talking about what? Say you want some information about, let's say, 3 people. Then what are you looking for? Number one, say you are looking for their age. Or it can be a very big survey, it doesn't matter. Here I'm just saying, says you want to do a survey about 3 people or whatever. Say the first thing that you're going to ask them is their age. Say you're going to ask them about the age. And then what is the next thing? Maybe you want to ask them about their weight. And what is the next thing? Maybe you want to ask them about what? Say about their academia, qualifications or whatever. Say here, academia. Now, the first person, let's say this is the first person. Let us call him X. Then you ask him his age. He say, no, I'm 25 years or 35 years old. Then you say, what is your weight? Then he say, no, I'm 62 kilograms. And then what is your academic qualification? Maybe say what? I only went up to primary. I only went up to primary. I didn't finish primary. And then you move on to the next person, interested person. Say you ask him, let's say you call that person Y. Say, what is your age? Then he say, no, I'm 27 years old. What is your weight? You say, I'm no 57 kilograms. Then what is your highest standard academia? No, I went to primary or say secondary. Let us say secondary. I passed only grade 11. Then you meet the third one. Let us call Z. What is your age? Say my age is 21. What is your weight? Say my weight is what? Whatever, say 42 or 48 kilograms. Then your academia, say yes, I passed grade 12. Maybe I did a a diploma somewhere, say tertiary. Then from there, you can do as many, and then from there, you want to present this in a reader-friendly way. Then you can use matrices to present this information in a reader-friendly way. What you are going to do now, it will depend now. You can just say, or draw a table, or table is not even necessary. You can just draw what now? Use matrices now. And say, the first column, I'm going to capture the information of the first person. And in the second row, I'm going to capture the information of the second person. In the third row, the information of the third person. Or alternatively, you can say in the first column, I'm going to capture the information of the first person. In the second column, I'm going to capture the information of the second person. And in the third column, it will be the information of the third person. But before that, you need to do some coding, especially here, to say, okay, what am I going to use for which number or primary? I'm going to assign it which numerical number. Then you can just say, oh, for primary, I will use 1. 1, it means primary. Then from the secondary, I will denote it by 2. And tertiary, I will denote it by 3. Or you can just say primary, I will denote it by 0. And secondary, I will denote it by 1. Therefore, tertiary, I will denote it by 2. It doesn't matter. So here, let's say we are now going to capture the information of the first person in the first row, where we know now, then the first element that we are going to capture is 35. And then what about the weight? Then it will come here and say 62 kilogram. And what about the academia? Then we're going to say 0, where we know 0 means, or it stands in our information, it stands for primary only. Now, what about the second row? Then we're going to capture the information obtained from the second person, where the first column now, it will be the age. Because then it means this is age, this is weight, and this is the level of education. And this is the first person, this is the second person, and this is the third person. So now here it will not be followed by 57 because we're talking about the weight. Here, secondary, you write 1. Then from here, the third one, it will be 21, followed by 48, and then followed by 2. And then from there, you are done. But then it will depend on, then you have to give us the key to say the row is the information of the first person somewhere. Or simply rows refers to the information of the persons. Therefore, obviously, the first column, it will be about their age, so on and so forth. Then from there, instead of writing everything like this, then you will have this information nicely in a matrix form. And that's it. Now, if this is fine, then we can now move on to the definitions now. If this makes sense, then you can now move on to the, but please, just one thing is what? Please read the question, because the question can be very explicit and to say, capture this information where the information of one person are in row form, or where the information of a person are in column form. So because this one is about what? This it represented is for the information of the first person, is in row form. But now if you want to capture them in column form, then it will become this. It will now be 35, 62, 0. These are the information of the first person. And then this one, it will be 27, 57, 1. So then this will only be 21, 48, and 2. So read the question and answer it. Otherwise, if it is not explicit, then you can either write this, but then you explain it, or write this and explain it. But if it is explicit, to say capture it like this, then there's no need to then go further and even explain it. Hopefully that makes sense. Now, with matrices, we can go further with the definition. We have defined what an order is. Now, what about if you have got something like this? Say A is equal to, it has got only whatever, it has got only one row. Then we call it a row matrix. A row matrix is a matrix that has got only one row. Then what will be the order of this? Anybody? If you have been asked about the order of this one, what is the order of this row matrix? It's a row matrix because it has got only one row. But what about its order? Anybody? What is the order of this? It is what? How many rows? One row. And how many columns? 1, 2, 3. Therefore, this is a row matrix of order 1 times 3.
1 by 3, sir.
1 by 3. The same thing with a column matrix. Let's say B. A column matrix simply means it has got only one column. Then how many rows? It doesn't matter. So it can be what? Say -1 here, 3 here, and -4. How many columns? One column. Therefore, is a column matrix. But what about its order? It's a column matrix because it's got one column. But now what about its order? Don't forget, you start with the number of rows. So it will be how many rows? 1, 2, 3. Then it will be 3 by 1 matrix. But don't forget, it's a column matrix. So on and so forth. What about what we call a square matrix? A square matrix is a matrix in which the number of rows are the same as the number of columns. A square matrix, it has got what? The same number of rows as are columns. Let's say you have got 2 here, you have got 3 here, then you have got what? 4 here, and you have got 0 here. How many rows? 1, 2. Therefore, it will be 2 by, and how many columns? 1, 2. It has got this. Then this is, it will be called, it's an example of a square matrix. It's a 2 by 2, or it can be 3 by 3, or it can be 4 by 4. It can be 7 by 7, as long as these rows, that would be an example of a square matrix. Now, another thing is what is called a diagonal matrix. Diagonal matrix. What is a diagonal matrix? A diagonal matrix is a matrix in which we know what a diagonal is. In a parallelogram or a rectangle like this, a diagonal is this straight line joining this. So even in here, a diagonal, it will be all the elements that are in here. So then a diagonal matrix, it will be a matrix in which all, let's say what? All the entries are 0. A diagonal matrix is a matrix in which all the elements are zeros. except the ones which are on the diagonal. That is, say A here, say 2 by 2, and you have got a 2 here, and you have got a 3 here. And then here, you have got 0, you have got 0. Then you can see that this one, they are in the diagonal. If you see this as a rectangle, this, they will be in that diagonal. Then what about this? It's not in the diagonal. What about this? It's not in the diagonal. Therefore, this is what is called a diagonal matrix. It's what is called a diagonal matrix. And now, the next thing is what is called an identity matrix. And what is an identity matrix? Identity matrix is a diagonal matrix. And because it's a diagonal matrix, therefore, all the elements are zeros except the one on the diagonal. But then, these elements in the diagonals are 1 entries, meaning this is 1 here, and this is also 1. Therefore, this is an example of what is called identity matrix. And normally, it's just denoted by I. So it's an identity matrix of order 2 by 2, or just let me say 2. Hopefully, that makes sense. Now, what is a null matrix? A null matrix is a matrix in which all the entries are zeros. That is called a null matrix. A null matrix. All the entries are 0. 0 here, 0 here, 0 here, 0 here. It will depend on each order. You can say 0 here, 0 here. You can say 0 here, 0 here, 0 here. All the entries are 0. Therefore, this is a null matrix of order 3 by 3. So on and so forth. Hopefully that makes sense. And what is a symmetric matrix? A symmetric matrix is a matrix in which what? The elements in the first row are the same as those in the first column. Elements in the second row are the same as those which are in the second row, in the second column. I mean that. The elements in the third row are the same as those in the third row. The elements in the fourth row, so on and so forth. It will depend on its order. Can you give us an example? Or just have an idea of what we're talking about? That is a symmetric matrix. Symmetric matrix. It will be like this. Let's say, can you write the elements in the first row? Let's say you have got 3 here, 0 here, 4 here. They're in the first row. Therefore, they must still be in the first column. That is, they must still be in the first column. Therefore, you must have 0 here, 4 here. Otherwise, already, it fails to be a symmetric matrix. Then, elements in the second row. Say you have got 7 here and you have got 8 here. They are the elements in the second row. Therefore, this 0, 7, 4, they must still be here in the second column. Therefore, what must be the entry here?
8.
0, 8. It must be 8 here. Otherwise, it fails to be what? A symmetric matrix. Say you have got 6 here. Or no, let me not say 6 here. let me ask you, what must be here so that this becomes a symmetric matrix? What must be here now? What must we have here so that this qualifies to be a symmetric matrix? Which number must we write here? Mujise or Mujishe?
3, I think.
3. Okay. Mujishe says 3. A new Pala. What must we have here so that this qualifies to be a symmetric? Anybody?
3.
12.
If not 3, it will be easy. Let's say 5. Somebody says 5. Let us say 5. Those who said 3 do agree with 5 here. If we write 5,
think
because you okay, say, will it still qualify to be symmetric?
So can you please just explain the symmetric
Yes,
again?
Symmetric matrix is a matrix that what? We're saying for a matrix to be called a symmetric, we're saying it must have what? The elements in the first row, they must be exactly the ones in the first column. The elements in the second row, they must be exactly the ones in the second column. The elements in the third row, they must be what? In the third column. Otherwise, that is not a symmetric. Otherwise, that is not a symmetric matrix. Does it make sense now?
Yes, thank you.
Yes.
Yes, the question is this now a symmetric matrix?
Yes.
Okay, let's change this one here and write, say, 10. Is it still a symmetric matrix?
Yes.
Okay, let's change it and write -1. Is this still a symmetric matrix?
Yes.
Let's change this to say 6. Is it still a
No,
symmetric?
no, it's not a symmetric
No.
anymore.
Now you understand it.
Yes.
Because the elements of the second row, which is 076, the elements in the second row, which is 076, they must be here. And this is not 076. This is 078. Therefore, this is not a symmetric matrix. Then we can move on now. We can move on to something else. Let's say this. Let's say you have this. 1 here, 0 here, 0 here, 2. Is this a symmetric matrix? Is it a symmetric matrix? Anybody? Is it a symmetric matrix? Silence, it means trouble. Is it a
Yes, it
symmetric
is.
matrix?
No.
Helen?
Yes. Yes, it is.
If you say no, then it means trouble. If you say no, then it means trouble. Why? Because what are the elements in the first row? It's 1, 2. Therefore, this 1, 2, they must be the elements in the first column. What are the elements in the first column? It's still 1, 2. No, it's still 1, 0. The elements in the first row is 1 and 0. The elements in the first row is 1 and 0. This 1 and 0, they must still be the elements in the first column. Are they the elements in the first column? Yes. Now you go to the second row. You have got 0, 2. Then there must be still be what? The elements in the second column. Are they still the elements in the second column? Yes, 0, 2. Therefore, this is symmetric. Then this is symmetric. Hopefully that makes sense. But if you change
Yes,
this
it
and
does.
write 3 here, if you change and write 3 here, is it symmetric?
No.
No, because the elements in the first row is 1, 0. The elements in the first row is 1, 0. What about the elements in the first column? It's not 1, 0. It's 1 something. Therefore, this is not symmetric. This is not symmetric. It's not symmetric. Let's say you write 0 here and you write 1 here. Is it symmetric? Say, Piso, is it
Yes.
symmetric, this? Yes, it's symmetric.
Yes, sir. Yes, sir.
Now, if you understand this one, then we can now move on to the next definition. Because the two, sometimes many students, they tend to confuse them. So then let us then move on to what is called a transpose. Let's say you have got A here. We're talking about transpose. Transpose. Transpose, in transpose, let us start with symmetric. Symmetric is one matrix. Symmetrics, we're talking about one matrix. Is symmetric. We're talking about one matrix. But in transpose, we're talking about two matrices. It will be matrix A and matrix B. So in transpose, you have got this. 1 here, say 2 here, say 3 here, say 4 here. It's matrix A. Then its transpose, meaning another matrix. Let us call it B. Let us call it B. That is where we're saying in transpose, you will be talking about two matrices. Now, this matrix B, it will be called the transpose of matrix A. This matrix B will be called the transpose of matrix A if these elements in the first row, they are the same elements in the first column of matrix B. And this element of the second row in matrix A are the same as the elements in the second column of another matrix B. This in matrix A in the first column, they constitute the elements in the first row, no, in the first column of another matrix. This one in this matrix, they constitute this one in the next matrix. Does it make sense? As Nati has put us on hold. Does it make sense? You see the difference between a symmetric matrix and transpose of a matrix. And because of these two matrices, we call one the transpose of the other one. Then if this one, we call it A, this one we don't use a different letter. We still stick with letter A. And then we write A exponent capital T. But these are two matrices. How are they related? Here we have just swapped the rows and the columns. This is the first column, then we swapped it. It's now the first row, it's now the first column. Oh, this is the first row. We have now swapped it. In the second matrix is now the first column. These elements, we have just swapped them. They are now the second column. Unlike in a symmetric matrix. Does it make sense?
Yes.
Yes, it does. Say you have this. Let us just extend this. Put more here, put more here, put more here. Say 0, 3 here. No, not 3 because we are not running short of numbers. And say -1 here, 6 here, and -6. Then what is the transpose of A? Just write it there. Let me give you 2 seconds to write the transpose of A. If this is A, matrix A, then what will be its transpose? Hopefully you are done. Just write it there, so that when we give the answer, then you can just compare it to yours today. Just 2 seconds, write the transpose of this. 2 seconds. You now have only one left. Ah, we are done. What will be the transpose of A? Anybody? Remember, nobody here is wrong. You will only be wrong in the exam, not today.
130.
Come again?
130.
130.
Yes.
It what?
As a row.
As a row. As a row.
Okay. 130. It will constitute the first row.
Yeah.
And what next?
245.
245. Constitute.
As a row.
As a row, as the second row.
Yeah.
And what else?
-1, 6, -6 as a row.
Which row?
Third.
Third one.
Row. It will be this. And that's it. It's very simple. And this is very crucial in the next session, which will be next week. So imagine if you cannot get it, the transpose, and which we are saying is crucial, we're going to use it. Come what? Come the next session. Or anybody who got a totally different answer? The good thing is what? This is unique. This is the only correct answer. Anything else, it will be 0. Anybody who got something different? That is anybody who got 0? Did you get 0? Tepiso? No. Who got 0? Who need to be congratulated? Nobody. Then let us then move on then. Let us then move on. Or even before we move on, let us just try and test your knowledge here and ask you to classify this. Classify this. Just tell us what is this. Oh, no. Let us just finish. Let us just add more. Let us just add more matrices and say a lower triangular matrix. A lower triangular matrix. A lower triangular matrix, it will be a matrix, a lower, it will be a matrix, a lower. Let me just create more space here. A lower triangular matrix, it will be a matrix in which all the elements above the diagonal are zeros. Lower triangular. All the elements above the diagonal, they are zero. Say this is the diagonal. You have got what here? 1 here, 2 here, 3 here. Meaning it's going to be a 3 by 3. So anything above this, it must be 0. So then you have 0 here, you have 0 here, and you have 0 here. And below this, they are now non-zeros. Then it will be -1 here, maybe -2 here, and whatever here, -3. And you can see that these are the elements in the diagonal. These are the elements in the diagonal. And above this, they are all zeros. And below, they are non-zero. So then this, it will be a lower triangular matrix. So if you understand this, then what about upper triangular matrix? Upper. Then it simply means what? Upper, it simply means these ones now, they swap. These ones now are zeros. And these ones now, they are non-zeros. These ones now, they are non-zeros. Therefore, this, it will be an example of an upper triangular matrix. Now, matrices are equal if they are equal in all respect, meaning if their corresponding elements are the same, are equal. Matrix, we're going to say these two matrices are equal if their corresponding elements are equal, meaning an element in the first row, first column in the first matrix is the same as an element in the first row, first column. Element in the first row, second column is the same as the element in the first row, second column in another matrix, so on and so forth. Otherwise, the two matrices will not be equal. Like this. Let me ask you. Let's say you have got A here. It's 1, 2, 3, 4. And you have got B here. It's 1, 3, 2, 4. Are these two matrices equal? Are they equal? Are they equal? You look at 1. Is an entry in which row? The first row. Entry in which column? The first column. Is it equal to an entry in the first row of B and first column of B? Yes. What about these two? It's an entry in the first row. Which column? Second column. Then it must be equal to an entry in B in the first row, second column. So first row, this is the first row. Which column? Second column. Then this must be equal to this one. This must be the same as this one. This one must be the same as this one. This one must be the same as this one. If not, then you cannot say matrix A is equal to matrix B. They are not the same. Yes, they have the same order. They have the same order. They are all 2 by 2 matrices, but they are not equal. Even if you can have 3 here, are they equal? Because this one is the same as this one. This one is the same as this one. This one is the same as this one. The only difference is these two. Can you say matrix A is equal to matrix B? No, because these two, they are not the same. Therefore, these two matrices are not equal. They have the same order, yes. They are all 2 by 2, but are they equal? No, they are not equal. Hopefully that makes sense. Now, before we go far, let us try then now and test our knowledge. How? By classifying the following. You tell us this matrix is so and so. Let's say it's A here. I've written some here. Say it's 4 here, it's 3 here, it's 1 here, it's 3 here, it's 2 here, it's 5 here, it's 1 here, it's 5 here, it's 6 here. Can you classify it? In other words, you just tell us whether this is a null matrix. If it is a null matrix, therefore you write it is a null matrix. If it is a diagonal matrix, again, you write it is a diagonal matrix. If it's symmetric, you write it symmetric. If it is a lower triangular, you write it. If it is an identity matrix, you write it, so on and so forth. Looking at it is, which one does it satisfy?
Symmetric and the square.
Let's start with, let us just take them one by one. Which one?
Symmetric.
It's symmetric. Symmetric. Let us check first. Is it symmetric?
Yeah, second it's symmetric.
Yes. Let's check. Are these entries of the first row, are they the same as the entries of the first column? 4, 3, 1, 4, 3, 1, yes. What about 3, 2, 3, 2, 5, 3, 2, 5, or 3, 2, 5? Yes, 3, 2, 5. Element in the second column, yes, is the elements in the second row. 1, 5, 6 elements in the third column. 1, 5, 6, yes, is the same as 1, 5, 6. Yes, it's a symmetric matrix. What next now?
A square.
Is it a square? That is what? Are the number of columns the same as the number of rows? How many rows? 1, 2, 3. How many columns? 1, 2, 3. Yes, it's an example of a square matrix. Anything else? Anything else? Is that all?
3 by 3.
Yes, you're talking about the order. What is the order of this? It's a 3 by 3 matrix. We're not talking about the order. It's a 3 by 3 matrix. Anything else that you can say about it is? No. Okay, let's say this. A, say 1, 0 here, 0, 2. Can you classify it? Number one, classify it. You tell us which definition does it meet?
Diagonal matrix.
Diagonal.
It's a diagonal because all elements in the diagonals, they are not zeros, and everywhere else is 0. Therefore, it will be is an example of a diagonal matrix. Anything else?
In the square.
Symmetric.
Is a square because it's a 2 by 2. It's a square because it's a 2 by 2. Anything else?
Symmetric.
And it's also what? A symmetric. And what else? Can you say is a lower triangular? Is it a lower triangular?
Yes.
Now the question is, what is a lower triangular matrix? A lower triangular, it means what? All the elements above the diagonal are zeros, and below they are not zeros. We've said you talked about what? A lower triangular. So no, it's not a lower triangular. If you put 3 here, yes, it's a lower triangular. If you put 3 here, yes, it's a lower triangular now. But now, is it still a diagonal? No, it's no longer a diagonal. Is it a square? Yes, it's a square. Is it symmetric? No, it's not a symmetric. But if you put 0 here, then it's no longer a lower triangular, but it's this 3. But again, if you put 7 here, let us classify it now. Is it still a diagonal matrix? No, it's no longer a diagonal matrix. What is it now? Is it still a symmetric?
Matrix.
Is it still a symmetric? No, it's no
No.
longer a symmetric. This is just what? Two.
Upper triangular.
It's an upper triangular and what? And a square.
Square.
It will be a square and an upper triangular. Why are we looking at this? We are saying, as we have said, maths is what? It's a language. If you miss the definitions, then surely you are going to get it wrong. Because this definition will be needed to solve some problems. And if you are still not sure about a lower triangular, a symmetric, and what, because in the next section, we will be using those terms. So then if you're not sure about those terms, if you're not competent about those terms, then you are not going to follow. And that is why we're trying to what? To spend some time on the definition and so on and so forth and so forth. Let's say you have got this. Says 1 here, 0 here, 0 here, 0 here, 1 here, 0, 0, 0, 1. Can you classify this as much as you can? Can you classify it?
Identity matrix.
An identity matrix. Why? Because it's a diagonal matrix in which all the elements in the diagonals are 1. It's a diagonal. Why? Because all the elements which are not on the diagonal, they are zeros. It's a diagonal matrix because all the elements which are not here, they are zeros. Therefore, yes, it's a diagonal matrix. Then you write it. It's a diagonal matrix. Yes, it's a diagonal matrix. What else now?
Symmetric.
Is symmetric. We all agree, symmetric. The elements in the first row that are exactly the elements in the first column. The element in the second row that are exactly this. The elements in here, they are exact, therefore it's symmetric. What else?
Square.
It's a square because it's 3 by 3. 3 rows, 3 columns, therefore it's a square. Anything else? Anybody? Ukise? Is that all? Okay, yeah, that is all. It's only these 3. The diagonal symmetric is a square matrix because the order is what? It's a square. We are not going to write 3 by 3. We're going to write, say, it's a square. If you want to classify it, we're not going to say 3 by 3. We just say it's a square. But now, tell me this. What will be its transpose? Let me just give you 3 seconds. Write the transpose. Just write its transpose. Remember, in transpose, you just swap them. In transpose, you just swap them. What was in the first row, it will not be in the first column. What was in the second row, it will not be in the second column. What was in the third row, it will not be in the third column. Are we all done? Writing is transpose. Are we all done? These elements, they will now be the elements of the first column, meaning it will now be what? 1, 0, 0. And this. What about this one? It will be in the second column. It will now be what? 0, 1, 0. What about this one in the third row? It will now be in the third column. That will be 0, 0, 1. Therefore, the transpose of an identity matrix, it will just give you the very same identity matrix. The transpose of an identity matrix, it will just give you the same matrix back. Unlike maybe if you put whatever somewhere, unlike if it is not an identity matrix, then their transpose, they are not going to be the same. Say you have got, no, we don't even need an example. As long as you understand this concept, the definition, what do you mean by an identity matrix? And what do you mean by a transpose? It will depend. Hopefully that makes sense. Now, with this now, we can now go to what we call matrix operations. But for today, we're going to look at how do we find the sum of 2 matrices or more matrices? How do we find the scalar multiplication of matrices? How do we find the product of 2 matrices? The quotient is not defined. You cannot divide one matrix by the other one. You can only add, you can only subtract, you can only multiply a matrix by a real number, and you can only multiply 2 matrices. And even multiplication is not always defined. You may find that matrix A multiplied by matrix B doesn't make sense. It's not defined. Then I add 2 matrices. Now, they must have the same order. The sum of 2 matrices will only make sense, will only exist if those 2 matrices have the same order. That is, they are all 2 by 2 or 1 by 1. Don't forget, this is a matrix. It's a matrix. As long as you have got these square brackets, then you are defining it's a matrix. How many rows? 1 row. How many columns?
1.
1 column. Therefore, this is a matrix. What about the order?
1 by 1.
1 by 1. Is it symmetric?
Yes.
Yes, it's symmetric. That's right. It will be, it's a square because it's 1 by 1. It's symmetric. Is it a diagonal matrix? No, you can't say it's, no, it's not a diagonal matrix. Remember, a diagonal matrix is only those elements in the diagonal which are not zeros. Anything everywhere, it must be 0. And here we don't have anything everywhere. It's only this one. So you can't say it's a diagonal matrix. Okay, so on and so forth. But what we're saying is what? You can only add two matrices if they have the same order. Let's say you have got one matrix here. Say one here, whatever here is a 2 by 2. And then we have got matrix B here, another matrix. Say 10 here, 12 here, 0 here, minus 1 here. What is the order? 2 by 2. Therefore, we can find the sum of these two. Then how do we add them now? How do we add them? We add their respective elements. That is, this now 2, it must be added to 10 only. Then it will be what? It will be 12. So on and so forth. This now, it must be added to this. Minus 3 being an element in the second row, first column. Minus 3 being element in the second row, first column. Then it must be added to an element in the second row, first column. Then which is minus 3. This one, which is an element in the first row, second column. Element in the first row, second column must be added to an element in B, which is in the first row, second column, which will be 13. And this one, no, this one must be added to this one, which will be 3. And this is the sum of A and B, which you can call it C. But now the question is addition here, if it is defined, is it commutative? That is, will A plus B be the same as B plus A? The answer is yes. A plus B is this, which will be the same as B plus A. And we know if we can just swap the numbers around the plus, then we know we're going to say they are commutative. If you say 2 plus 3 is the same as 3 plus 2, then we're going to say, oh, then we have used what? Commutative property. So on and so forth. So if you add another matrix here, say matrix D, say it has got what here, 0 here, 1 here, 7 here, 8 here. Now the question is, will A plus B plus D be the same as A plus B plus D? In other words, now used what? An associative property. Will this be the same as this one? The answer is yes. As long as they are defined. Don't forget, addition of two of matrices is not always defined. It will only be defined if the two matrices have the same order. In other words, if you add this here, say here, what, minus 2 here, and say 1 here. Will A plus B be defined? Are we going to have an answer here? Say A plus B. Are we going to have an answer? Are we going to have an answer? Is it defined in other words? Yes, tell us, Majie. I know you have an answer. Are you
No,
receiving it for the exam? Will this be defined? Are we going to have an answer here?
no,
No. Why?
because the other one is a 2 by 2 matrix and the other one is a 2 by 3.
The other one is 2 by 2. The other one is how much?
2 by 3.
2 by 3. We will give you an opportunity to correct yourself. Yes, A is 2 by 2. A is 2 by 2.
I mean,
But what about B?
sorry, 3 by 2.
Yeah, this one is 3 by 2. Because they don't have the same order. Therefore, we cannot add them. The problem, it will be what? What about this one?
The last row.
Yeah, that is the third column, the third row. We're going to add it to what? Because this one, it doesn't have 3 rows. Therefore, this row, the element in the third row here, they're not going to find their partners in here. Therefore, this is not defined. You cannot define it. So on and so forth. So here, what about 3 multiplied by A? 3 is a real number. So this is what is called scalar multiplication. Then how do you get this now? 3 multiplied by matrix A. Don't forget, 3 here is not a matrix. So now how do you get this? It will be 3 multiplied by, then you write the elements of matrix A, which is 2 and 1, minus 3 and 4. Then now you are going to multiply each element here by 3. You're going to multiply each element in this matrix by 3, which means it will be 3 multiplied by 2, you write the answer. 3 multiplied by 1, you write the answer. 3 multiplied by minus 3, you write the answer. 3 multiplied by 4, you write the answer. Therefore, the scalar multiplication of this, it will be 3 multiplied by 2 is 6. 3 multiplied by 1 is 3. 3 multiplied by this minus 9. 3 multiplied by this. Therefore, that's right. Meaning what? You can still what? Because this is 3 multiplied by A, then you take the 3 inside. The other way around is what? You can still take the 3 out here. As long as all these elements, they have got the same common factor. As long as they have the same, they have a common factor, then you can take that common factor out. Hopefully that makes sense. You can take the 3 inside, multiply each element by 3. Here it is. And you can still get what? As long as they have a common factor. Here, 3 is a factor, 3 is a factor, 3 is a factor, 3 is a factor. Then you can take the 3 out. Hopefully that makes sense. That makes sense. Not in this one, not in this one. Say you have got 8 here, then you have got 2 here, you have got 6 here, then you have got 9 here, then you have got 12 here. Yes. This is a factor 2. This one is factor 2. This one is factor 2, but this no factor 2. But if you take the 2 out as a common factor, then it will be 2 in brackets what? What are you going to write inside? It will not be what here? 1. Here what? 3. What about this one? Because we're going to take the 2 out. Then it will be 9 over 2. Then this is going to be 9 over 2. And this one be what? This one be 6. Or you can write this one as 4,5. Or we know it. 4, 1 over 2. 4, 1 over 2. Or what? You can write it as 4,5. Write it like this. We took the 2 out as a common factor. That's right. So hopefully this makes sense. Now, with this now, let us look at the last operation for today. The last operation is how do you get the product of 2 matrices? The product of 2 matrices. But before we look at that, let us look at a condition. Let's say you have got a matrix A here and a matrix B here. You can only get this, the product of this. That is, you can only get this, A multiplied by B. If, only if, and here in multiplication, AB is not necessarily going to be the same as BA, unlike in ordinary real numbers, where 2 multiplied by 3 is the same as 3 multiplied by 2. You see, 2 multiplied by 3 is 6. 3 multiplied by 2 is this. Therefore, multiplication is commutative. Multiplication is commutative of real numbers. The same story. Addition of matrices is commutative. Addition of matrices is commutative, meaning what? The order is not important. But here, with multiplication, which we have said does not always exist, and we're saying in addition to that, you may find that AB is not the same as BA. AB, yes, exists. BA, yes, again exist, but their answers are not the same. Hopefully that makes sense. And in some instance, you may find that only this one exists. BA doesn't exist. Or even if the two exist, you may find that the two are not the same. Now, multiplication of two matrices or the product of two matrices will exist if the following condition is satisfied. Let's say, what is the order? We normally write the order at the bottom. We say 2 by 3. This is a matrix of order 2 by 3, where the first number refers to the number of rows, that the second one refers to the number of columns. Now, for the product to exist, let's say B here, and let's say multiplied by here. This matrix B, it must be 3 by any. Let us pause here. It must be 3 by any. In other words, the number of columns here, they must be the same as the number of rows here. This one, it doesn't matter. This one, it doesn't matter. Hopefully this makes sense. This can be 4. This can be 6. This can be 2. This can be 1. As long as these ones within are the same. Does it make sense? If you get here, yeah, then we can look at the process now. How do we multiply? Make sure that, okay, let's say you have got this, say 2 by 3, no, say 2 by 4. Then we'll say multiply it by what here? Say what? Whatever, say 3 multiplied by 2. The product exists. Will the product here exist? Any response? Will there be an answer here? Are we going to find an answer here? We're multiplying these two matrices. A is of order 2 by 4. This is of order 3 by 2. Will there be an answer? I thought everybody will have an answer here. Maybe except me. Will there be an answer here?
No, sir, because I think for A, we said we're looking at the columns, and then on B, we're looking at the rows. So they must be equal. So in this case, I don't think it's possible.
This one, for anybody, maybe Somebody see it differently?
No, he's correct, sir. He's correct. I agree with you.
That's right. These two, the one within, inside, just write them like this. This one inside, they must be the same. Are they the same? No. Therefore, A by B will not exist. A by B will not exist. But the question is, what about B by A? B by A. Will it exist? B by A.
Yes.
Yes, B by A will exist. Why? Because what is B? B is 3 by 2. B is. What about A? A is 2 by 4. And this one inside, they're the same. 2 here, 2 here. Therefore, this one, yes, will exist. Therefore, there will be an answer. Therefore, BA will exist. Not AB. AB will not exist, but BA will exist. So now the question is, how do we get the answer now? How do we multiply the two now? Multiplying the two is, at first, it will look like it's complicated. But with 2 or 3 examples, then you will see that, oh, this is very simple. Let's start with something very small. Let's say what? 1, 2, 3, 4. And B here, let's say what? Don't forget, this is a 2 by 2. It's a 2 by 2. Now, say this is -1 here, 0 here, whatever. Let's start with something small, -2 here, and whatever, something different, -4 here. This also 2 by 2. It's also 2 by 2. So therefore, what about AB? Meaning this is A2 by 2 multiplied by B, which is also 2 by 2. Because these two are the same, therefore the answer will exist. Therefore, there will be C. And how do you find that C? And most importantly, what will be the order of C? The order of C, the order of the product, is these outer numbers. These outside numbers. These ones. It will have this order. The one inside, it will tell you whether the product exists. What about the outer ones? This one and this one. It will be the order of the product. Then we know this one is going to be 2 by 2. The answer here is going to be 2 by 2. To be 2 by 2. Then how do you get that 2 by 2? And this is how you do it. This is how you do it. Let's clear this. This is how you do it. Let us just get straight to the answer. You take this. You multiplied them by this. Take it slow. You say 1 multiplied by -1 plus 3 multiplied by -2. That will give you an entry of the first row, first column.
Sir, your board is a bit up. We can't see the A. Thank you.
Good. Does it make sense? Let us go through this in slow motion. We're saying what? How do you get this? How do we get this one? We're saying you use these elements in this first row. You multiply them by the elements of the first column. How do you multiply them? You say this multiply by this one. What is the answer? -1. Then you say
-1.
plus this multiply by this one. So it will then be -1 plus what? -6. Hopefully that makes sense. And then the answer here, it will now be -7. Are you done? Then again, from there, you must now get an element here. You still use these elements in the first row. You now multiply them by what? The elements in the second column. The way we found this. You will now take this and multiply them by this. It will now be what? 1 multiplied by 0. What is 1 multiplied by 0? 0.
0.
Plus what? 2 multiplied by -4. What is the answer? -8. So therefore, this now, 2 minus 8, it will be this.
Sorry, sir.
Yes?
Can you please repeat how did we get -7?
No, don't worry. I know this is mathematics. This is nice. We will repeat, go through it again. Eh? But do you know how to get this -8? How did we get -8? But don't worry, don't worry. Let us finish it and go back again. Okay, let us just start again. Nobody will blame you. Mathematics is nice. What we are saying here is what? To get the elements in the first row. To get the elements in the first row. You use the elements of the first row of this. Because we are saying A multiplied by B. So to get the elements in the first row of the product, you use the elements of the first row of the first matrix. In other words, you take these elements here of this, meaning of A, meaning here of the first row in A, which is 1 and 2. You multiply them by the elements of the first column of the second matrix, meaning of B, meaning you multiply them by this. Does it make sense?
Yes,
you
sir.
see now. Then how do you multiply them? You say
It's
1, you say 1 multiplied by -1. What is the answer?
-1.
-1. From there, what? 2 multiplied by -2. What is the answer?
-4.
-4. But then how did we get, where did we get -7 then?
I think there was a mistake, sir. I think there was a mistake.
Thanks.
Yeah. It should be row by column.
That's right.
Yeah.
This row, first row by the first column. Then I don't know where we got -7. Then the answer here is -5, not -7. From there, what? This multiplied by this. This multiplied by this. So it will be this multiplied by this plus this multiplied by this one, which is how much? -8. Then how do you get the elements in the second row? You use now the elements here in the second row. Then you multiply them by what? The columns now. It will now be this multiplied by this. It will give you the answer here. Thereafter this multiplied by this, then it will give you an answer here. Does it make sense? So what will be the answer? It will now be this multiplied by this. Meaning it will be 3 multiplied by -1, which is -3, plus -8. It will be -3 plus -8. What is -3 -8?
-11.
-11. Then what about it is? The same story. It will be this multiplied by this. This multiplied by this. And what will be the answer? This by this is 0 out. This by this is how much? -16. This is the product of A and B. Now, for practice sake, just look at B by A. What is B by A? What is B by A? The first matrix is B. The first matrix is B. Therefore, we are going to, to get this elements here, we are going to start with the first row of B. The first row of B. Let me just take this out so that it can now be clear. Let me write it properly. Three, 4, 1, 2. Aha, good. -4, good. What about BA? We are now going to take this and multiply it by this and get the answer here. So this by this, then it will be this multiplied by this, which is -1, plus this multiplied by this, which is simply -1. Then you take this, you multiply it by this now. So it will be -1 multiplied by 2 is minus 2 plus this multiplied by this, which is 0, then it will be minus 2. Then already you can see that AB is not equal to BA. But you are not done. Then you are now going to use the second row of the first matrix. You're going to use this. So which will now, we are now going to use this and multiply it by this. Second row multiplied by this. Then it will be minus 2 multiplied by this, which is minus 2 minus 12. What is minus 2 minus 12? Minus 2 minus 12. Then from there again.
Can you please take your camera down? Yes.
Yeah, it's just that, yes. Then what about the last one? Just tell us the last one. The last entry here will be how much? The last entry here, just to make sure that you are with us. This one here.
Minus 20.
Is it correct? Genio? Is it correct, Mahatu? He say minus 20. Lesia? Mose? Ah, what is happening? Then it means you are not with us. What should be an entry here, an element here? You said it's how much?
Minus 20, sir.
But my worry is the others are not responding. Then it means they don't know how you got minus 20.
Yeah, no, I understand. It's row by column will be, the first one will be minus 4, and then the second one will be minus 16. 4 by minus 4 by 4 will be minus 16, and that first one will be minus 4. So yes, it's minus 20.
Yes, it's minus 20. But still my worry is what the others are quiet. Quiet, it doesn't mean that they understand it. Simply means that they don't know. Does it make sense? Then what now? Then you can go and multiply any now. You see, because here we started with something simple, 2 by 2. You can go and replicate this in 3 by 3 or whatever. So let's say this. Let us take it further. Let us just look at the last example. Say you have got this. 104. What? 2, 3 minus 1. This is how much? What is the order here? It is 2 by 3.
Can't see properly at the top.
It's 2 by 3.
Thank you.
Therefore, good. Therefore, you can only multiply it by means of which order? Let's say B here. You can only multiply it by a matrix of which order? Let's say 2. Yes, say we are going to say A multiplied by B. Therefore, B, it must be what? B must be what? B must be 3 by whatever. It can be 3 by 1, or 3 by 2, or 3 by 3, or 3 by 4. If it is 3 by 4, then Yes, it will going to make sense because this 3 is the same as this 3. But then the order of AB, it must be 2 by 4. The order of AB, it must be 2 by 4. This, if you say C, it must be 2 by 4. If you change it is to say 3 by 1, 3 by 1, 3 by 1, what must be the order of AB? Because it will still be defined. It must now be what? 2 by 1. It must be 2 by 1. It must be 2 by 1. So on and so forth. Let's say this is 3 by 2. Therefore, the order we know it will be 2 by 2. So, okay, just give us any matrix of order 3 by 2, 3 rows, 2 columns. Say this is -1, what here? Let us not write very big numbers. It must be 3, 0 here, 2 here, 1 here, it must be 3. No, then because it must be 3 by 2. This is out. It must be 3 by 2. This is out, say here, 1 here, 4 here. And what will be the answer here? Because we all agree this, it will be defined. This will be defined. What will be AB? There will be an answer. Because this one's in, because this is A here is 2 by 3, this is B is 3 by 2. Therefore, this will be defined. And then the answer is going to be 2 by 2. The answer is going to be this, 2 by 2. It's going to be 2 by 2. So what are those elements? A, we are going to take this and multiply them by this. So it will not be what? 1 multiplied by -1 is -1 plus 0 plus 4, which is 3. -1 plus 0 plus 4 is 3. It will be this. The next thing, this by this. Meaning it will be 1 by 3, which is 3. 0 by 2 is 0. 4 by 4 is 16. Then it will be 3 plus 16 is 19. We are done with the elements of the first row. What about the elements in the second row? We are now going to use this now because it's A by B. We are now going to use it as second row. It will be what? 2 multiplied by -1 is -2. 3 by 0 is 0. Therefore, it's -2 minus 1. What is -2 minus 1? -3. Then it's now this by this. It's now this by this, which will be 2 by 3 is 6 plus 6 minus 4 is 6 plus 6 is 12. 12 minus 4 is 8. Is it 8? Yes, it's 12 minus 4 is 8. Then if you compare it with BA, will BA exist? Will it exist, BA? Will BA exist?
Yes.
Because BA, it will now be what? B is 3 by 2. What about A? A is 2 by 3. Therefore, BA will exist.
Yes.
But what about its order? Its order, it will be 3 by 3. Therefore, you can see that there is no way that AB will be the same as BA. Because BA is 2 by 2. BA is going to be 3 by 3. Simply because they don't have the same order. Therefore, we cannot even talk about what? Their equality. Then you can go and what? And do as many as you can. 3 by 3, whatever, any number. It's just that it will not be a little bit, a lot of manual work. But if you have a calculator, then you could just use a calculator. That's all. I'm not saying using a calculator keying in the matrix, no. I mean using a calculator to say what is 1 multiplied by minus this, what is this multiplied by this, what is this? Not to simply say punch in a calculator, because there are some clever calculators and even AI, then you will be penalized. That's good. Any question? Then we are going to need this in the next session. In the next session, make sure that you know how to multiply 2 matrices, because we're going to take it from there. Assumption in the next session is what? You know how to multiply 2 matrices. Then if you know how to multiply 2 matrices, then from there, we are now going to take it from there, use it. Fortunately, you still have time. You can just simply go and practice until you get it right. Saturday, you come knowing how to get that product. Now from there, even the last session, the applications. Anything before we go? But tell me this, what does on hold mean? Helen, what does on hold mean? It means what? Okay. Let us not waste time on that then. Okay, then.
I think maybe.
Okay.
Maybe the
Any
person
question?
was using the divisor, the Bluetooth, and then maybe press it by mistake.
But
so it's off.
Can that person still be with us?
Yes, but he can't hear anything.
But then he's with us. He can, even if that person cannot hear anything. Okay, so let it not make it a discussion. Any question before we go? Any question before we go? Any question, Tawani? Going,
No,
go.
sir.
No, Mahatu. Make sure that you know how to multiply this.
I am good.
Good. Anybody in B? Marilana?
I'm sorted.
You didn't say anything today. Marilana, are you with us? Good.
Yes, sir.
Still, she can't say anything. Okay, thank you very much, dear. And then let us meet again Saturday, same time, God willing. Please don't forget to stop recording. Tawani?
Yes, sir. I'm stopping. Yes, sir.
Yeah,
I'm stopping now.
Yeah, stop recording and bye and see you later. God willing. Thank you very much.